Well, good morning, good afternoon, ladies and gentlemen. And I can actually say good morning, good afternoon, because we have people from Mexico, from Brazil, from Bangladesh, from Chile, from everywhere in Spain, by the sense of it, Argentina, Italy, Germany, I think there's someone here. So welcome everybody, and Dubai as well. Welcome everyone. We are talking today about designing bifacial PV projects, and we are delighted to have you all in here. We have a lot of people online. Partially part of the reason is because most of us working from home. I will start apologizing for my surroundings, but this is what it is like. As you know, we're here in a little bit of a quarantine in Spain. We can't leave our homes. Luckily, with things like webinars, we can still communicate and work and spread that information. So we're delighted to be here today and to be actually like helping people, find out more about bifacial PV projects. With me today, two experts on this particular topic, and I'd like to ask them to introduce themselves. Aniruddha, you go first. Tell us a little bit about you, your company, and where you're joining from today.
Hi everyone. First of all, thanks a lot for joining, from different parts of the world. Myself is Aniruddha. I'm from Silla and Wilson. I had the business development for Europe and Latin America. I'm based out of Madrid, but due to the ongoing situation, I am currently joining from India because I had to move out last week. Just a quick snapshot about Sterling and Wilson. We are one of the largest solar EPCs in the world with more than 9 gigawatt of the portfolio. And today I'll be speaking about some of our experience with respect to the bifacial technology. Having executed one project already in Middle East, it gives us a lot of insight, and we're really looking forward to this session today.
Thank you very much. Thank you very much, Aniruddha. Okay, Jose, how about you? Tell us a little bit about you, your company, and where you're joining from.
Hello, everyone. Thank you for joining us. This is Jose and from Soltec. I'm the CTO of Soltec Innovations, the R&D branch of Soltec Group. Soltec is one of the biggest tracker manufacturers in the world. We are the third one in track record, and we are here to talk about bifacial technology with trackers.
Excellent, thank you very much. Okay, so today's session goes like this. First we have Aniruddha from Sterling and Wilson, then we have Jose from Soltec, and we're gonna have presentations. You can use the Q&A box at the bottom to send us your questions, and we'll take them at the end, okay? So it's very straightforward. For you guys, I see a lot of names that I already know, a lot of people that follow our webinars, you know how it goes. Aniruddha, you want to put up your screen, please?
Sure, and, give me a second.
Yeah, sure, just put it up, prepare, and whilst he prepares, just to let you know, we are recording this session, and you will definitely have the presentations and the access to the recordings, so not to worry, it will be in your email in a couple of days. And just like that, we're ready. So go ahead, Aniruddha.
Thanks, Belen. I think it's a good time, like you said, Belen, it's a good time to arrange a webinar since most of our are working from home. Unfortunately, that's the option we have left now. Anyways, we will try to make the most of our time and see if we can learn a bit more about this technology. Quickly, just a summary of what we will be going through today in today's webinar. So we'll be talking about a bit on the bifacial, what is this technology is all about, what is the ALBEDO, because when we talk about bifacial, it is important to know what the ALBEDO is directly related with it. Some of the installation things, what we need to really consider when we are talking about this kind of technology, the changes in the BOQ, some of the economical parameters. What are the advantages if we are using this technology, and what are the disadvantages? And the last, we will see about what is the way forward, what could be the new possibilities in this field. So very quickly, so I think by now everybody is familiar about the monofacial technology, which is more prominent. If I have to explain bifacial, I would say it is turning out to be one of the most popular and one of the most inexpensive technology by which you can enhance your same given portion of the land parcel. Why? Because the bifacial PV modules can generate electricity not only from the front.
And just one thing, your sound comes and goes. Can you make sure that your microphone is up, right? Because we hear you wonderfully, and then you kind of shut out. Let's try.
Okay. Okay, let me try again. So basically, bifacial technology is all about making generating the energy not only from the front side of the module, but as well as from the back side of the modules. Why is it possible? Because when we talk about the bifacial module, there is no opaque or there is no backsheet in the modules. Basically, what we use is a transparent sheet by which the light can travel and it can reflect. Whereas when we talk about the monofacial modules, we use an aluminum shield or a black shield, to block the sunlight. So this is basically the major difference between mono and bifacial. I remember the last time I spoke on the same topic a couple of months back, the technology was still relatively new. But as we are advancing, more and more projects are shifting towards bifacial. In fact, almost 70% of the bids ongoing in the Middle East are now shifting from mono to bifacial. The primary reason, like I said, it's the most inexpensive and one of the most popular way to enhance your yield. If we talk about the difference in the cell, in the technology of the cell, I would say it is normally the similar way you have to manufacture the bifacial cell in the factory. The only difference what we have is instead of the rear back sheet, we will have a rear contact or rear passivation for the cell, by which we are able to generate electricity from the both sides. And this is just a classic example to demonstrate this what we just talked about. We are not using a white sheet.
Careful with the mic again. You were fine, and now it's going dropping off. Just careful with it.
Okay, I will try to hold it in my hand. So basically, but the bifacial PV module performance, like I said, it does not depends only purely on the modules, but there are a lot of other external factors like the albedo, like the way the installation is being done, the ground conditions. All of these are also impacting the generation, what you can expect from the bifacial module. So as an EPC, it is very, very important to factor in all the other conditions other than the module, which is definitely is going to be a key technology. And the tracker, which my friend Jose will be talking about, how the tracker suppliers can play a very important role in terms of boosting the gains from bifacial cell. So when we talk about bifacial, the important thing what we really need to know is albedo. And what is albedo? Albedo is basically the reflection or the reflectivity of the ground, wherever you're installing your solar plant. And this value can vary from 0 to 100. So normally what we have seen, the more the whiter the surface is, the albedo will be higher. Similarly, if you go to a blacker surface, which has the characteristic of absorbing the light, the albedo will be less, and the gain on the bifacial module will be relatively less as compared to the white surface. If you could see this chart on my screen, so basically we have tried to capture the albedo for some of the characteristic for a particular site. Like I said, the albedo for the white surface will be highest. So for snow, it can vary between 40 to 90. For the ice, it's less. For water, definitely it's relatively much lesser because of the absorption power. Then, so basically why I said the Middle East, we are seeing a lot of products being shifting from the bifacial is because if you look at the albedo for the sand, it is varying between 20 to 40, and anything about 20, which means that you could expect a gain of minimum 4 to 5% on a monofacial module if you compare it with the bifacial module. So this is one of the reasons why the bids are now shifting more on this technology. How do we capture the albedo? Basically, we have an instrument called albedometer, which is basically a pyranometer. Two pyranometers, one facing upside and one facing downside, trying to capture the irradiance for the surface and from the sky, and then it is the ratio of reflected light and the incident light, and that's how you calculate the albedo. It's a dimensionless value, so there is no unit to it. It can vary between, like I said, between 0 to 100. There are different other ways to capture the albedo or to determine the albedo. Some of the easiest way is to look for a table like the one I have shared with you. So depending on the ground condition, and if you have some of the pictures for the particular site, you can imagine what could be the expected albedo out of the project. Second way is, which is more accurate, I would say, and more recommended one, is to capture the on-site measurement of albedo. How we do it? We install an albedo meter. We do these studies for ranging from a days to a couple of months. So basically, as an EPC, we feel more comfortable if we are able to capture the data on the on-site measurement, because we are able to write down all the uncertainties in the project. If we are not able to do so, we have also an option to go for the solar GIS data or the satellite data for the albedos. But typically when you are using the solar GIS and satellite data, you always have to take certain cushion on the uncertainty for these values. So when we do the albedo installation, our recommendation is to capture the albedo not only at one location, but to capture at different location, depending on what is the capacity of the project we are looking at. For a 50 to 100 megawatt project, it is recommended at least 2 to 3 locations for the measurement of this albedo. And this measurement period can vary between a day, a week, or a month. So if depending on how much time we are able to get. Secondly, when we are installing the albedo meter, there are a couple of things which we really need to factor in, which with respect to the shading on the albedo, because even when we are installing the albedo meter at a barren land or where it is an unmanned land without any security, we intend to fence it. So the things what we really need to ensure that whenever you are installing the albedo meter, the ground need to be completely clear. If there are grass around, you will not get the actual value of the albedo. Secondly, the fence distance of the albedo meter need to be factored in. The minimum distance of fencing, depending on the height, should be at least 2 to 3 meters from the actual measurement instrument. And thirdly, I would say the way the data is being captured, the way the instruments, the calibration certificate of the instruments are equally important whenever you are installing an albedo meter. So ensure you have the right calibration certificate and you are buying the equipment from the right manufacturers to ensure there are less of uncertainties and the prediction on the yield side are more accurate, so that your financial model is more secure. So these are some of the ways by which we are capturing the albedo. In the option number 2, as an EPC, we are also backing the albedo, whatever albedo we are capturing through our measurement. We capture it and we back it with in terms of the performance guarantees and the bank guarantees we provide to our customers or to our clients. So what are the things which we really need to factor in when we talk about the installation side? There are a few things, like I said, it's not only about module, but tracker, which is one of the key technology, again, which helps in playing with the albedo a lot. The one way is the height of the tracker, so the more higher you go, the better the albedo will become, because the reflectivity index will be better. So the angle of inclination is key aspect by which you can improve your albedo. But of course, if you go on slightly, if you keep on increasing the tracker height, there will be additional factors we need to factor in, which is like wind load. If you install the tracker at a more than 2 meter height. Secondly, the foundation will become more deeper and more stronger, which is again a capex related point. So whenever you're taking a decision on what should be the ideal height to installing the modules on the tracker, the only way to decide is the LCOE. So we do the simulations for a particular project at various heights, and depending on the heights, your OPEX is also varying. So if you go for a 2 meter or 2.3 meter height of tracker, the OPEX will also vary, because then you have to clean the modules at a slightly higher height, and the entire arrangement will be slightly different from the nominal one what we have in conventional way of cleaning the modules. Secondly, I think the very important thing which as an EPC and as in developers people need to look at is how we are managing the cables, because we are now connecting the inputs are getting doubled. We are having inputs not only from the front side of the module, but also the back side of the modules. So the proper cable management becomes really, really important. There are few tracker suppliers who are already, giving a lot of emphasis on this. I'm sure Soltec also have certain solution around it. But the way we do it is the string cable always passes through the top tube. There is a picture, I think you can visibly see the cables are passing through the top tube. This is the way to minimize your shadow on the modules, because if you keep these cables as a loose cables, they will definitely going to impact your yield simulation because of the shadow it may have on these modules. Thirdly, which is mainly with respect to the frameless modules, are the clamps. If you between the frame and the frameless modules, definitely there is a commercial and the capex difference. And there is a difference in the grounding. If you go with the frame module, you have to go for the grounding. Without frameless modules, you don't have the grounding. But then you have the clamps. And in sometimes these clamps are the rubber clamps, and the tightening of these clamps becomes much more trickier during the installation, because if you tight it slightly high, if you put more pressure, it may even break the glass. So it is more important as an EPC to give a lot of emphasis if we are working with the frameless module. They are more delicate to handle, but they are again cheaper as compared to the frameless. So it's all about the LCOE, and it's all about the capabilities of the EPC to handle these kind of modules. This is some of the pictures, just to replicate, just to showcase how the clamps are being installed. You can see on the right side of your screen, there is a picture of the clamp. So these kind of clamps we are using for the frameless modules to hold the modules on the tracker. And on the left side, you can see the screen, which is typically showing the height of the tracker. So in both, so even on the tracker, we have two options. We have 1P tracker, we have 2P tracker. There are a lot of, I would say, differences in people's mind, whether to go with 1P or whether to go with 2P. As an EPC, we have worked already on a 2P technology for one of the projects we did in Oman for one of our clients, which is already commissioned. But I think it is not, I would say, as an EPC, it is difficult for us to draw any conclusion. Between 1P and 2P, both have their advantages and disadvantages. I would say it is more of a site-specific requirement, what we really need to look at. For some of the site, we are now seeing that 1P is turning out to be equally competitive as compared to 2P. But again, it's a site-specific decision what we need to really make. Secondly, let's talk about what changes in terms of your BOQ. So when you're shifting your technology from monofacial to bifacial, what all will be the possible changes? One change, which we all know, is the number of inputs which is going up, because your combiner boxes are going up, and the number of inputs to your inverter will again be going up. There are ways to reduce it. If you are able to get access to 40 ampere, 50 ampere fuses, it is possible to use Y connector. But initially, for the beginning, when the bifacial was turning out to be more conventional or more popular, people were struggling to use the Y connectors. But now we have the solution in terms of the fuses. Second is the DC cable will definitely go up. So it means when DC cable is going up, your trenching requirement will go up, and there will be a slight increase in your overall installation cost and in your BOQ cost. So these are the main, I would say, the changes in terms of the BOQ. We will talk about more economical consideration between these two technology. One is module. Even between modules, even between bifacial module, like I said, there are frameless, then there are two types of technology, P and N type, and then we have HGT also. So the module pricing can vary among these technologies as well. But the good thing is, between mono and bifacial, earlier there used to be a differential of almost $2 in terms of the capex of the module, which has come down drastically, which means for the same site, there may be a possibility to shift the technology from monofacial to bifacial without having much of the capex increase, which is turning out to be definitely turning out to be a game-changing technology for all of us. Secondly, in terms of balance of supply, tracker is one thing. People are still spending a lot of R&D on this. A lot of tracker guys are coming out with new innovation. There are companies who are claiming, increase in the albedo value by the way they are using, in terms of the foundation solution they are proposing with the tracker. So there are different ways of playing with the albedo and overall increase on the gain, but it all comes at a cost. So the increase in the tracker cost as we go higher on the height. Combiner boxes, yes, the number of inputs are going up. The clamps would be additional. So these are some of the parameters what could increase your capex when you're talking about bifacial. Installation, one is the foundation length because of the increase in the wind load, and because of the increase in the wind load, the foundation going deeper and stronger. And secondly, the cable trenching, which is basically the DC cable we are talking about. Then the land cost, so when we are talking about the bifacial technology and over comparing to monofacial, the ground coverage ratio for bifacial is relatively much lower than the mono, which means you may require a higher land parcel, if you want to increase the gain, further than what is expected from the same technology. O&M, there are still few queries, there are still few points which we really need to come out with. One is the cleaning for the backside of the modules, which is still a question mark. A lot of people are still trying to figure out the ways to clean the modules. Currently, the way we are considering is probably a manual cleaning, which is the only possible way to clean the modules at a given time. But the way the technology is advancing, we are expecting sometime very soon people will come out with innovative solution for the O&M. But definitely because of the maintenance of the albedo and to ensure that the grasses and everything, the ground conditions does not change drastically as compared to the start of the project, the O&M cost is going to be slightly higher than the normal standard cleaning cost and the maintenance cost for a project. I think the last point, financing, is turning out to be, this was an issue initially in the beginning, but now as the technology is maturing, this is relatively getting easier. The people are showing more trust on the financing side. If I'm not wrong, I think as on today, almost 3 gigawatt of bifacial modules are already installed or under execution, which demonstrate the confidence which is shown by the lenders. But this could be still a challenge when we are talking about this technology for the new countries, probably like Caribbean region, where solar itself is taking some time, to get mature. For the markets where solar is already mature, getting the financing for bifacial will be relatively much more easier as compared to the newer markets. So what are the advantages? Why we talk about bifacial over monofacial? So one is definitely yield. What it helps is it can increase your yield depending on 6 to 15%. With, I would say, for a particular site, without any much of R&D and without getting into much of detailing of engineering side, you can expect gains between 6 to 10%. And with slightly tweak in the engineering and getting into the nitty-gritty of tracker and pitch and the ground condition, we can increase the generation from up to 15%. Which is again a possibility to go higher, but that means initial investment to improve the ground condition. Second is, I would say, the durability of the overall plant and overall modules, because we are not using these are the glass modules, and we are neglecting the need of the aluminum foils. They are giving us more mechanically stronger modules. They can withstand for up to 30-year life cycle. So the typical warranty is what we get with this bifacial module is 30 years as compared to 25 years what the module suppliers are giving to us for the poly. Some are already proposing 30 for monofacial also, but for bifacial, it's becoming an industry norm now for a long-term warranties. Thirdly, I think it gives us a lot of flexibility in terms of the designing. So it does not really matter, which way you're facing the module, because bifacial also factored in the reflectivity factor of the ground condition. So the direction that modules are facing becomes less important. But again, when you are designing and when you are competing in a competitive bid, we have to run different simulation to still find out what will be the best optimal facing for these modules. Another thing which is considered, it is relatively new, but could be probably a new, I would say, innovation for regions like Kazakh, Russia, where there is a issue with the snow load. People are now talking about vertical installation because with vertical installation, the actual yield can further go up by 20% to 25%. But this technology would be more useful for, like I said, for the places where we have issues with the heavy snow loads. And this is still not as mature as what we have seen in the other technology. Warranties, I already said, it's basically 30-year lifetime. But another good thing what we get with bifacial is the annual degradation, which is 0.5% as compared to poly or mono, which is between 0.6 to 0.7%. PID free, this is one of the key factor when we are using bifacial, because we are not using any backside material. It reduces the risk, and because of this, the modules are PID free. So basically, potential induced degradation is completely zero for bifacial. And then the last point is mainly for the frameless module, where we do not need any grounding because there are no frames to the modules. But in case of with frame modules, grounding is still required because the framing is the aluminum what we have. What are the issues and what are the disadvantages? So we talk about the advantages for the bifacial, but what could be the possible issues with this technology? One is because we are using glass, they are double glass. The weight of the module is becoming heavier, which is making the tracker cost goes up. Because of the heavier module, the tracker need to be more heavy. The structure is becoming heavy. That is one. Second, the ALBEDO, maintenance of the ALBEDO. So this is purely OPEX cost. If your ground conditions are changing over a period of time, it will definitely going to impact your financial model or your financial understanding what you had from the beginning of the project. So it is very, very important to give enough emphasis on how do we ensure to control the ground conditions to ensure the ALBEDO is not changing drastically over years. OPEX, like I said, the OPEX is higher as compared to the normal standard maintenance what we do on the monofacial module. Some of the questions are still unanswered on the backside of cleaning of the module, but sooner I think we will have some solutions for this. Whether framed and unframed modules, there are a lot of time people ask these questions. Unframed modules tend to cause less backside shading, but see, all of these is related to the site. I think we cannot conclude it is in a black and white that bifacial frame is better than unframed or unframed is better than the frame. It is more dependent on the site characteristic. But one important thing in both the things, what we really need to factor is the rear shading. Where the tracker guys are definitely going to play an important role. Currently, the rear shading, what we are seeing is ranging from 5%. And typically, these kind of shading we take from the tracker OEM recommendation. And there is a lot of area of improvement in this side. We feel that this 5% of rear shading can definitely go down to 3%. And we have already started seeing in a couple of competitive tenders, we have participated in Middle East where people are expecting to do so. So I think rear shading is one thing where we need to definitely optimize more in improving the generation. And what are the way forward in this technology? I talked about vertical installation, which is useful for the areas which has heavy snow load. By this kind of installation, we can definitely negate the load on the modules because we are installing the modules vertically. Help us in increasing the yield further to 10 to 20%. So if you are expecting a 15% gain on the bifacial, by installing vertically, you can expect further additional gain on 10 to 20% on the bifacial. Second technology we are working is on the double peak profile. Basically, it's a kind of east-west, but again with the bifacial sort of modules. This again helps you in improving the generation drastically. And third is the technology, which is relatively new, and we still need some more time because the albedo for the water is not as good as we have seen for the ground. But people have started exploring and doing a lot of R&Ds on this side, is the floating on the bifacial. I think it will take some more time for floating to be successful with bifacial, but with the kind of innovation we are seeing in the industry on a weekly basis, you know, it could be a possibility. So I think just to summarize, you know, as an EPC, we are comfortable in all sort of technologies. We have seen the advantages and disadvantages with mono, with bi. Each technology has its pros and cons. It's more about site-specific characteristics, what we have to really look at. And I think the way the industry is moving forward, we will have slightly more innovation even on the bifacial very, very soon. So thanks a lot, Belen. I think I would like to summarize my presentation.
Thank you very much. It was a long but very interesting and very detailed presentation. I'm going to ask you to take your screen off so that, Jose, you can prepare yours. And one thing, we have a lot of questions, and I know that you're very good with your typey thing. So I'm going to ask you, because we're not going to have a lot of time at the end, to answer those by text, please, if you may. And Jose,
sure.
Can you please take your microphone off as well? Yes. There's a bunch of them that are very specific for trackers, so you know we can go to those later. But in the meanwhile, if you can solve some of them, it should make it easy for us. Jose, I need your microphone on. Perfect. And can you make that larger, because I can still see the PowerPoint with the two settings?
Yes. Now?
Yes, perfect. You're ready to go. Go for it.
Okay. I will start my presentation. This is about designing bifacial PV projects, specifically with solar trackers. And I will talk about our PV field experiences with bifacial technology. Okay, this is the index of this presentation. I will introduce the Soltec with our track record so far with bifacial technology. So you have an idea of the reality that this technology is already today. Then I will tell the story about our bifacial experience since 2015, our first plant till this year. And later I will go in detail about how was our first bifacial PV plant in Chile, La Silla, and its results. Later I will talk about our bifacial tracker evaluation center in Livermore, California, where we are testing several configurations. And I will explain the results of that a full year of data of that test site. And then I will go slightly over a couple of examples of large PV plants with bifacial technology with our trackers. I will finish with some operation and maintenance considerations regarding this technology and trackers and what to do and what not, and the conclusions. So we start with our track record. Soltec is the third tracker manufacturer in the world in track record this year. We already have more than 9 gigawatts in total. Here are the numbers all around the globe. I will mention everything, but 3 of those gigawatts are bifacial trackers. Okay, so this is more than a reality. It's already, probably by this year, it will be half of our production in bifacial technology. Okay, and we expect it to go up. Our bifacial experience started in 2015 in a plant called La Silla in Chile, where we developed the first tracker ready to install bifacial modules. It was a very special site, and I will explain later in a specific slide. And later in 2017, Soltec launched the SF7 bifacial, our standard bifacial tracker, and with some advantages, some differences from the standard trackers to make it higher performance versus the one-ported trackers. In 2018, we inaugurated the Bifacial Tracking Evaluation Center in Livermore, California, where we installed a unique site for testing several ALBEDOs, GCRs, tracker designs, and to collect all the data and see what happens. So we have a fair comparison. And last year and this year, 2020, we already accumulated 3 gigawatts in projects already delivered or shipping or being installed right now. And these are some examples. Starting with La Silla, it was a special site because it's a commercial PV plant, 1.8 gigawatts divided in 3 fields. One of them was with standard modules, another one with standard modules with optimizers integrated in the junction box, and the other field was with bifacial modules. Okay, the GCR was 0.33, and this is how it looks like. This was the tracker that we installed. We left a huge gap in between the dog tube, the modules on the dog tube to avoid any shadowing. We also left some open spaces in between each 4 modules. We left open spaces just to make sure the light was going through the structure. And the results, for the first year in that PV plant were already shared by our customer. The average was 13.3 bifacial gain of the bifacial modules versus the standard modules. We also got the results for the modules with the smart modules, no, with the optimizers, and they realized that it didn't make sense to use that technology because it wasn't paying the effort of increasing that performance. But the bifacial is clearly increasing the performance and not affecting that much the capex of the installation. These are some figures that were shared by our customer. The levelized cost of electricity could be reduced 7.2% for 15% of bifacial gain, and this 13.3 was the bifacial gain that we obtained with the bifacial modules technology back in 2015. Now this year we have some improvements in this technology, and we can expect even more. That's why here we have this 15%. I will go over these details and start talking about Bifacial Tracker Evaluation Center in Livermore, in California. This plant that we installed in California is made up with 28 trackers, and we wanted to get long-term bifacial tracking data from different scenarios. We wanted to recreate conditions equivalent to large utility-scale PV plants, and we wanted to characterize all the variables affecting the bifacial performance, like the albedo. Albedo is the most important variable, the most important factor to take into account with these plants. GCR is also very important, the height to the ground, and shading and interferences of the cabling and the tracking structure. So we want to get the bifacial gain, taking into account everything and playing on with all those parameters in this plant. Our main target was to optimize our tracker to get to a better design than our current design, to develop advanced bifacial tracking algorithms, and also to improve the simulation parameterization. And this is something very important because it's hard to get to an agreement with all the models and how to simulate accurately these bifacial sites. Sorry. This is the layout of the plant, where we can see here in this corner 1P trackers. We have 3 rows of 1P trackers with a constant GCR. And then we have 2P trackers all around the plant with different albedo configuration. This white ground is a special material that we installed to improve the albedo. The green is seasonal albedo, where we left the ground to change according to the seasons. And in here we put some gravel. It was white at the beginning, and later we will see how it changed with the seasons. So we were testing different GCRs, different tracker designs, and 3 different albedo configurations. An important thing is to note that these blue trackers are the ones that we are considering in our study. So they represent more accurately what we will see in a real plant, in a utility scale plant. So we use the central modules of the central trackers in order to get more results more closer to the reality. Usually we see test sites, we see in many places, we see laboratories and other companies with showing test sites with just 1 tracker or just 1 row of modules, and it's good, but it's not accurate. So after the first full year of field data in BITEC, here we represent the results of the bifacial gain for different albedos. This is the 19.9, the seasonal albedo, and this is how it was changing with the seasons. We have fall in yellow, winter in blue, spring in green, summer in red, and the full years in gray. The gravel average 29.5, and for this white material, initially white, then it changed a little bit. The average albedo for the full year was 55.6. We can see a bifacial gain ranging from 7.3% to 15.7 in the best case. In this slide, we can see a comparison of the results for the best albedo situation, 55.6, comparing the 1 portrait and 2 portrait tracker configurations. And this is how they perform based on the same modules and the same GCR configuration, but 1P versus 2P. We can see how at the end of the year, we get 15.8 in the 2P and 13.6 in the 1P, and how it was constantly over the 1P during the whole year. These results are based on energy performance at module level, okay? And only the internal trackers were considered. And in this slide, we see a table. It's a bit difficult to understand, but I will try to explain. Okay, this is again the comparison and with an analysis of the parameters that are affecting each of the factors. Okay, so if we go, this is 1P, this is 2P, and this is what we call view factor. Okay, according to the view factor is the direct relation between the height to the width of the tracker. The 1P is higher than the 2P. Okay, the shaded area reflection is a bit higher in the 2P. This is because of the shadow is lighter because the modules are farther to the ground. The diffuse light is slightly higher in the 2P. This is also because of the absolute height of the tracker. And then we have here also a difference in the 1P versus 2P. we lose some energy due to torque tube shading, and we are avoiding any gap, any shadow from the structure or cabling to the backside of the modules in our tracker. This is the radiation through gap. This is actually the radiation that we can get reflected back from the torque tube to the backside of the modules, thanks to this gap we are allowing. And this is the mismatch. Okay, this is a parameter that is slightly lower for our 2P tracker versus the 1P. The temperature is another surprise because temperature loss, energy due to temperature loss, loss of energy due to temperature is minus 5.1, and the 2P is minus 3.9. And this is because of the height of the tracker, the absolute height, because the modules at the higher level are exposed to cooler winds and winds with higher speed. Also, the cooling itself is performing much better with that height. So at the end, we get almost 2.1% in the total comparison. These are, in the last column, we see the equivalence with PVC's parameters. So if you want to simulate with PVC's each tracker, these are the parameters to touch in the software. Here we see some examples of large PV plants already installed with our trackers. This is Magdalena 2 in Mexico, 219.5 megawatts with our SF7 2x42 bifacial. These are 6,533 trackers already installed, up and running in Mexico with this technology. GCR is 38.4, so it means that for installing these plants and getting a good bifacial gain, you don't need to go to lower GCRs. The lower you go, the better, but you still can get this profit with these GCRs. Okay, the operation started in Q4 2019. This is another example, San Gonzalo 1 and 2 in Brazil, adding 608.67 megawatts in a single bifacial plant with trackers. You can see here the Jinko modules, the Jinko boxes. This plant is so large that started last year and is still under installation and commissioning. We have 17,568 trackers in this single plant. And in this plant, they are playing with two different GCRs due to how the layout was designed. The average albedo of this plant is 25%. So we don't expect them to add anything to improve this albedo, probably. And these are two realities of plants that are encouraging our customers to continue with this technology and also with our results. I will finish with the O&M considerations. These are examples of how our test site in Livermore, in California, was changing along the year. It's the same piece of land, but with a lot of colors. So this is something to take into account, to have in mind that if we want to keep a constant, or if we want to guarantee some average albedo level along the year, we have to take care of the ground, and we have to work probably more. Also, some other things to consider is the bigger spaces in between trackers, the easier is to access for cleaning and for removing the grass. So if you have big machinery for removing the grass, you will need a big clearance in between trackers. So for the same GCR, if you install 2P trackers, you'll get easier access under the tracker. As you can see here, these 140 trackers are that low to the ground that the machine wasn't able to access to the center part. So, and this is affecting a lot the backside of the bifacial modules. So this point I already mentioned is the clients need to guarantee an average yearly albedo, and this is something that the designers, the plants, the tracker manufacturers, and the people working in O&M have to consider. Albedo enhanced materials, what they call AEM, are getting attraction and are already being deployed in some large-scale plants. And we are also working in some product around this together with our trackers. And these solutions also require maintenance during the life of the plant. You need to clean the material, you need to remove the plants around or underneath, and in some cases you need to replace them during the life of the plant, and that's something to consider. And here are our conclusions. Okay, the main influence is the albedo and the seasonal variations. We can play with the albedo, we can ensure the albedo and guarantee some values, but we have to there will be an extra cost for the O&M. So it has been already 5 years since our first commercial plant with bifacial trackers. It was La Silla plant, and that was a very good start for us. The data from that plant is encouraging us to continue with this technology. Our clients who already have tried with our trackers and bifacial plants have the numbers, and they are continuing, they are repeating with our technology. From our BITEC plant, we get 15.7% of bifacial gain with reasonable high albedo, and 7.3 with seasonal albedo. These numbers are already quite good and higher than expected initially. And we also should mention that the bifaciality of the modules is improving lately, so we can expect much more from here. Also, the material we use for improving this albedo is not the best. We are testing with much better materials, and we can expect this number to go higher this year. So the comparison of two portraits versus one portrait after 1 year of data is 2.5 higher, and the main difference is the lack of shading, the rear side of the module, higher distance, and I'm talking about absolute distance in between trackers and absolute distance to the ground, and also due to the lower operating temperature of the modules. Bifacial technology is a reality, as you have seen in the two examples. Very impressive, 608 megawatts with bifacial trackers in a single plant in Brazil. And also we have to consider the operational maintenance to keep and to guarantee that the performance is going to be as we expected. That's all. Thank you.
So thank you very much to both of you. These have been quite lengthy presentations, so we don't have a lot of time for questions. I'm just going to ask, actually, can I ask you to take off the presentation of the screen, please, Jose? Actually, guys, I know that you've been doing a very good job. You know, you got through a lot of answers. I think you must have answered about 30 questions. We don't have a lot of time, so I'm going to ask, you know, you can actually like questions, and there's a couple of questions here that have 4 likes. So I'm just going to ask those 2 questions. And I'm sorry that, you know, there's like another there's at the moment 33 questions open and 34 have been answered, so we just don't have time. So one, Elena asks, can you tell us some GIS or satellite data based to obtain information about albedo values? Is there any data? But I mean, it's really hard.
Yes.
Talking about. So let us know.
So the question is for me, Belen?
Sorry, go ahead. Yes, you answer.
Yeah, okay. So basically, yes. So in the PVCs, solar GIS also gives us albedo for a particular site. But like I said in my presentation, the GIS data or the satellite data, whatever we use, we always have a room for uncertainty, which can vary between 3% to 5%. Hence, it is always advisable as an EPC and as an IPP to have the on-site measurement to keep no room for these uncertainty, given the kind of competitiveness we have seen in the recent past globally in solar. These kind of uncertainties make us uncompetitive, and hence for the initial assessment, we can definitely go with solar GIS data because that will give us a good insight about the potential of bifacial for that particular site. But if we decide to move forward, it is recommended to have the on-site measurement. Anyways, the albedo cost, the albedo meter does not cost you much. The cost can vary between $10,000 to $20,000. And by having these kind of data, we can secure the financial model in a better way. So that's my recommendation, Belen, on this.
Yeah, there was also a question about how much it costs and stuff. So you've answered a few questions at the same time.
Yes. Yeah.
There's another question, and Jose, you can then jump in, and answer those as well if you want to add anything. Is it practical to install mirrors at ground level to increase albedo and reflect sunlight directly back to the underside of the PV panels? So, there's like an extra added of mirrors. I don't know how you would manage to keep those clean, but anyway.
I don't think it's a good idea because the rear side of the modules get diffuse radiation. Okay, that's what they see. And if you try to direct the light with mirrors, you'll have to move the mirrors to try to send the light to the right spot in the rear side of the modules. So mirrors will reflect light depending on where the sun is, and not in a diffuse, not diffuse light. It will be direct light. It's much better to use something white, and white materials are already available from some manufacturers. So and that's what we are testing right now.
Okay, white materials. One more question is my own, there is so many open that in terms of the banks, how are the banks taking it with this new technology? What kind of guarantees or technical assessments or like financial, whatever, what is it that they want to see in order to go to back a project like that?
So initially, Belen, so banks were reluctant when the technology was a bit new, but after executing more than 3 gigawatt of projects, globally, what Jose also showed in his presentation, I think banks are now more comfortable. And this is something which an IPP and the EPC both have to really take it up. If you have an EPC who's backing up the generation gains in terms of giving you the performance bond and the warranties, and not only for the year one, but also for the subsequent year, which can go down after year 2 into the O&M contract. The banks are finding it comfortable. We are seeing most of the bids in Middle East already happening the large scale. When I say the bids in Middle East, they are always more than a gigawatt plus going into bifacial. I think the bankability is definitely improving, but it can be a challenge in the newer countries. Like I already mentioned, for projects in Caribbean or the projects in Africa, where bankability with the normal modules is still a difficult task. Bringing in bifacial can be challenging on those markets. But for the mature market, I think it is very much accepted and welcomed.
Excellent. Well, I'm really sorry we cannot take any further questions now. We will forward you guys the questions so that you have an idea what people have been asking for. And thank you very much, everyone else that is there. I look forward to seeing you in the next webinar. Thank you very much, Anirunda. Thank you very much, Jose, for teaching us so much today. I'm glad to see how much this technology has come along in the past few years since we started doing webinars on this. It's really interesting. And the floating PV, you know, like bifacial PV is just insane. So, all right. Thank you very much and see you next time. Bye.
Thank you so much. Stay safe.
Bye.
Stay
Thank
clean.
you.